Okay, Assalamualaikum. Okay, so today we proceed with the diagnostic for the normality assumption actually. Okay, so from the previous lesson or your previous knowledge, you know that the diagnostic for the in order to proceed with the regression analysis, okay, we need to do the diagnostic checking for the residual first, which is it is the assumption for the linear regression is the residual should be linear, that uh, we discussed that matter on the previous lesson, right, on the on the linearity. And then the residual should be normal, and the residual should be independence and also have constant variance, right? So for the previous lesson before this, you have learned how to check for the linearity of the regression function, which is we use the lack of fit test and also the scatter plot, right? So dekat sini dekat page um, 103 and above. Okay, 103 and above. This is the diagnostic, okay, residual for the residual. Diagnostic checking for the residual actually. So untuk non-linearity, you boleh check, boleh tengok juga lah dekat 105, which is it mention about the scatter plot. It explain about the scatter plot, how to see whether the linearity of the regression function is fulfilled or not. Okay, kalau yang ni contoh-contoh the linearity not fulfilled, right? Sebab ada nampak quadratic curve here. Okay, and also you have learned uh, how to check using the lack of fit test. Okay, you dah buat tadi tu lack of fit test dengan syaratnya level of X must be repeated. Okay. And then we also actually untuk nak check for the linearity, boleh juga sebenarnya check gunakan residual plot, residual versus X dan residual versus time. Tapi dekat sini ni tak nampak, I'm not sure kenapa dia tak nampak kat sini, tapi in your textbook you boleh tengok lah dekat page 106 tu. 106 ni. Okay, dekat page 106 tu dia ada beberapa contoh figure 3.4, beberapa contoh of the residual plot, which is the residual versus X. Okay, which is dekat A ni sebenarnya kalau you tengok your textbook adalah beberapa contoh. A tu adalah the point are scattered randomly around 0. It developed the horizontal band, so we can say that from there juga we can say that the linearity assumption is fulfilled. Okay, kalau dekat sini lah kita tengok yang ni residual plot. Okay, contoh-contoh residual plot. Okay, kalau we have this residual plot, we can see also using the residual plot ni kita boleh juga katakan that the regression function is linear. Okay, ini pula adalah contoh-contoh the residual plot of the when the linearity assumption is violated. Okay, and then we also need to know about the Nernst constancy of the error variance. Okay, boleh gunakan sama juga tadi residual versus X and juga residual versus fitted actually. So we need to plot the residual versus X, each of X or residual versus predicted. Okay, you know how to find the residual, which is yi minus y hat, right? So just plot that. So if this plot, okay, if this plot berada dalam horizontal band, okay, around zero, which is scattered randomly. Okay, tak ada nampak any pattern. So we can say that the residual have the constant variance. If like this, there is increasing pattern kat sini ataupun dipanggil megaphone. So we can say that the residual do not have the constant variance ataupun dipanggil heteroscedasticity. Okay. Ini contoh yang tak constant lah. This is the example of the constant variance plot of residual versus fitted. Okay, and then this is the beberapa contoh plot of the residual versus fitted ataupun versus X pun sama. Kalau patternnya macam ni, ada megaphone, dia ada a pattern sphera here or the quadratic pattern here ataupun linear pattern ke. Okay, kalau ada linear pattern pun sama juga. Yang kita nak untuk residual versus fitted ataupun residual versus X ni, kita nak patternnya tak ada pattern, no pattern, have no pattern or scattered randomly around the horizontal band zero. So it is saying that kita boleh check untuk constant variance. We can say that the residual have the constant variance. We can check for the linearity. So we can say that the regression function is linear, and also boleh check juga untuk independence. Okay? The other assumption adalah independence of the error term. Okay. Okay, ini contoh kalau Y versus X dia ada outlier here. Alright. Boleh juga untuk independence sama ada kita check gunakan residual versus fitted ataupun residual versus X tadi. Also we can plot the residual versus time. Okay, versus time order here untuk independence. So if here kita dapat macam ni, okay, so dikatakan the residual is not independent. Okay. Okay, figure 3.8a contains a time sequence plot of the residual in an experiment. Okay, an evident correlation between the error terms stands out. So negative residual are associated mainly with the early trials and positive residual with the later trial. So ini adalah contoh untuk non-independence of the error term. Okay, sama juga kita boleh check juga for the sama juga dia punya pattern. If it have the no pattern ataupun the points scattered around horizontal around zero, so it is the independence. We can say that the residual have the are independence. The residual are independence ataupun independence of the error term. If we have this type of pattern, ada nampak dia punya trend yang di sini ada nampak macam cubic. So this ataupun cyclical. So this is the types of non-independence situation of the error terms. Okay. So apa yang I nak fokus hari ini adalah non-normality of the error terms. Okay, actually we have several ways to check for the non-normality of the error terms. Okay, the residual should be normal. Kita nak check ni. Okay, so sama ada boleh gunakan box plot, ataupun boleh gunakan histogram ni, box plot untuk residual, histogram untuk residual. Okay, you know how to draw the box plot. Contoh box plot kalau dalam your textbook ni dekat page 104. Okay, let's see sekejap. Page 104, ini contoh box plot. Okay, ini contoh box plot. Dia ada dari from this box plot akan ada minimum value, maximum value, kat sini first quartile, third quartile and the median. So daripada box plot ni kita boleh tengok whether there is a symmetrical distribution, whether that distribution is normal or not, symmetric or not. Okay. So kalau ada tail ataupun dia punya whisker is longer, so that means that the distribution are skewed. Okay, kalau symmetrical, median ni berada di tengah-tengah. Okay, tapi dikatakan this box plot is not obviously skewed. Okay, apa yang boleh you check lagi adalah boleh gunakan juga histogram. Okay, you know how to draw the histogram. Juga boleh gunakan stem and leaf plot. Tapi not recommended sangatlah gunakan this plot. Okay, yang kedua adalah gunakan comparison of the frequency, which is kita akan gunakan when the number of cases is reasonably large is to compare with the actual frequency of the residual against expected frequency under normality. So this method also is not frequently used by the researcher. Yang selalu digunakan adalah we use the normal probability plot ataupun boleh juga gunakan test of the Kolmogorov. Okay, Kolmogorov test. Okay, boleh juga gunakan test. But here I explain about the normal probability plot. Okay. So untuk the plot for normal adalah each residual is plotted against its expected value under normality. So we need to have the residual value, which is you know how to find the residual value yi minus yi hat untuk dapatlah residual for each observation, and then we need the value of the expected value under the normality. But usually no need for you to draw the probability, the normal probability plot manually, because of we can we can construct from the SPSS ataupun using the software which is the SASE guide. Okay, later I akan tunjukkan. Okay, so this is the contoh normal probability plot when the error term is not normal. Okay, which is kita akan tengok kat sini, dia akan ada di sini kalau the normal probability plot showing the normal showing the normal assumption is fulfilled. Okay, which is we saying that the error term is normal if the normal probability plot is like this. Okay, so kita akan nampak kat sini the plot here is approximately ataupun most of the points approximately lies along the straight line. Okay, so we can say that this situation, this plot, showing us that the normality assumption is fulfilled, which is the error term are normal. Okay, the rest of the plot here adalah contoh yang normality assumption is violated. Okay, not fulfilled. Okay, kita ada nampak kat sini ada some of the point berada di straight line, tapi akan ada tail kat sini. Ada heavy tail. Okay, sini pun sama juga. Dia ada heavy tail, so we consider that the normality assumption not fulfilled. Okay, same here. Okay, dia ada tail. Sama ada right tail or left tail. Okay, sama juga kat sini contohnya yang ni dia terbentuk kat sini adalah skewed to the right. Okay, sebab kalau kita buat sebenarnya kalau ada straight line dekat sini dia berada di sini, so dia punya plot ni terbentuk di bawah. Ini adalah right skewed. Okay, right skewed to the right. So normality assumption is not fulfilled. Ini contoh untuk skewed to the left. Okay, nampak quadratic here. And here, dia ada symmetrical tapi ada heavy tail. So we also consider this is not normal. Okay, this is the some of the example for non-normal error term. Okay, so we have this, if we have this this plot of normal probability plot, we can say that the error term are normal ataupun the normality assumption is fulfilled because of most of the point lies along the straight line. Okay. Okay, so because of that, we can see that the error term is normal. Okay, look at here. Kat sini ada explanation about each of the graph here. Okay. And then, so kita baca kat sini, difficulties in assessing normality. The analysis for model departure with respect to normality in many respects more difficult than the other types of departure, which is constant variance, independence, and also the linearity. In the first place, random variation can be particularly mischievous when studying the nature of a probability distribution unless the sample size is quite large. Even worse, other types of departure can do affect the distribution of the residual. For instance, residual may appear to be not normal distributed because of an inappropriate regression function is used or because of the error variance is not constant. Hence, it is usually a good strategy to investigate these other types of departure first before concerning oneself with the normality of the error terms. So, before we check for the normality, check dulu untuk independence and also the constant variance and also the linearity of the regression function, because of sometimes when the error is not constant, so dia akan akan mempengaruhi juga normality assumption. So for the practical ataupun for the application after this, you should check we should check for the other departure first, barulah kita check untuk normality. Okay, and then like I said before tadi, just now, we also can check the normality using the test of the dipanggil Kolmogorov value kan. Maybe that one you have learned before this in diploma. Okay, rather than the normal probability plot, we also can check using the Kolmogorov. Okay, that's all for diagnostic. So maybe later I will show you how to to check for the constant variance using the test. Okay, using the test.